Welcome to another tutorial in ANSYS Workbench 18.1. In this video we are going to import a CAD model, apply boundary conditions, and determine a solution. So to begin with, we will come over to Static Structural, left click, drag it to the project schematic screen and let it go. This brings up our tool menu. We can type in a title here. I'll type in CAD Import. For the engineering data, we'll go ahead and use the construction steel, which is the default, so we won't make any changes. I come to Geometry, right click. It brings up this drop down, and I will simply click on Import Geometry, Browse. Now I'll go find my file that I'm going to import. And here's the file. This particular file happens to be an IGES file, and I click on it and then click Open. My geometry now has a green check, but that's not quite true because I need to go in and do a geometry check before I can go to Model. So I will double click on Geometry. It shows that it's starting space claim down here in the bottom with the red dot. This can take some time when you're opening a CAD model that already has a geometry in it. So I'll go ahead and close the default window. There's my geometry. It's been imported. I can rotate it around. This happens to be a bicycle disc brake, and you can see the geometry here has an inner support, an outer brake pad, and then various surfaces and bodies to do the connection. Over here in the structure tree, you can see all the components that exist. I can scroll through and collect these, and you can see the little highlight box that is generated when I click on a particular component. This has 20 components, and now in order to bring these into ANSYS Mechanical, I actually need to check the geometry, and I can do this one at a time, or I can do it on all the components at the same time. So I'll click the top component, scroll to the bottom, and control click the bottom component. So I can come over here to the structure tree and see all the components that have been imported as part of the geometry. As I click on the various components, a box lights up around that particular component. Now in Space Claim, before I go to ANSYS Mechanical, I actually need to check the geometry in all of these components. To do that, I will click on the top or the first component and then shift click on the last component to select them all. Then I right click while in the list of components, and I click on Check Geometry in the drop down window. As it goes through and checks the geometry, it can take some time in a large model, and it says no geometry problems were found. So I can go ahead now and close Space Claim and open my model. Now you can see that the geometry has been brought into ANSYS Mechanical. You can rotate your geometry around and look at the various components. Over here in geometry, I can see that all these solid components have been brought in. I can again click on the various components to highlight that particular component. I can also come over and just select it in the window. So I can close my geometry. Coordinate systems, I don't need to do anything. I'll just use the default coordinate systems. And connections, I don't need to do anything because the connections were developed when I brought the geometry in Space Claim. So I'll generate a mesh now. Right click on mesh, left click on generate mesh, and I will look at using just the default mesh that is generated. So that's done. I can left click on mesh and see the mesh that was the default, and as you can see, it's a very coarse mesh. It's not a very good mesh. I'm actually going to do one mesh refinement. So I'll come to mesh, right click, insert, refinement, and left click on refinement. Now I need to go select the geometries or the bodies that I want to, where I want to refine the mesh. I'll click on this outside body and then control click the inside, and I'll control click each one of these circular members here. Once I've selected several, I'll go ahead and click on geometry and apply, and you can see that I was able to select 8 faces. The refinement that I'm going to do is only a little bit of a refinement. So I click down here on refinement and I increase that from a 1 to a 2 by clicking on this arrow. Then I go up and click update mesh. Again, you can see that the mesh is in progress as the model status window pops up showing the mesh. Once the meshing is done, all of this window will close and I'll be able to look at the mesh. I will go ahead and pause the video while the meshing completes. So the meshing is completed. I can now click on my mesh and see a significantly more refined, better mesh. Around each of these holes I have a pretty high mesh density, and out here in the inner member I also have a pretty high mesh density. So I will go ahead and use this mesh. I come and right click on static structural, insert, and I'm going to insert a fixed support. The fixed support that I'm going to put on is going to be on this inside race, so I will click on surface select. I'll rotate my body around and click on that inner surface, rotate my body and control click on that inner surface, and now I have the inner surface of this inner member selected, and I will click apply to apply that. I can reorient my object by clicking on my x-axis and looking into my geometry. I will now apply a torque on this outside member. To do that, I go to Static Structural, right click, Insert, Moment. I need to click the geometry that I'm going to look at, and I'm going to put it on this outside face. So I left click, rotate my body, Control left click, and I now have that outer surface selected. I click Apply. I don't want to define by vector, I want to define by component, so I'll click the drop down on Define By and select Components. Now I want to apply a moment about the x-axis, so I'll come to the x component and enter a moment of 1000 and click on the structure, and now I can see that moment has been applied. My boundary conditions are all applied. I have green check marks. My forces, or my moment in this case, has been applied. I'm ready to select the solution options. So I right click on Solution, left click on Insert, and I will select Deformation and Total. Right click on Solution again, Insert, drop down to Stress, and look at the equivalent von Mises stress. Right click again, Insert, and I'll insert a stress tool and a maximum equivalent stress, and that's all I'll select for now. So now once I have all the outputs selected that I want, I right click on Solution and click Solve. The solve starts, and you can see the progress of your solution down here in the solution status. Now that my solution is finished, I note that I have two warnings. It says at least one body has been found to have only one element, and this is where I would need to go back and look at the individual bodies more carefully and see the elements that are in those bodies, and likely do a mesh refinement in some of these smaller bodies. The other warning says that the maximum contact stiffness is too big, and this may affect the accuracy. And so I would need to go back and look at the stiffness that was developed between the various contact elements in the body. But I'll go ahead and live with those warnings for now. You can see that I have green check marks on my solution output. I can look at the total deformation and see what the results look like. If I want to change the colors in my color bar, all I need to do is come over here and click and scroll, grab that and pull down and change those colors, and you can see how they change in the graphic as that happens. I can also decrease that and scroll the other way to change the colors. I can increase the number of boxes that I have representing that in the color bar, and so that can be a nice feature to change those colors. I can look at the stresses, the equivalent stress, and do the same thing by changing the color bar and essentially making it a little broader by scrolling down. And now you can see some red areas develop where the stresses are high. You can see that this member in here is more stressed than the outer member, that there are some relatively high stresses in these little notches. I can look at my stress tool and look at a safety factor and you can see the safety factor. And this completes the tutorial on importing a CAD model. I hope you enjoyed it, and thank you for watching.